Hi, and welcome to today's presentations. The topic is going to be top visualization tips and tricks to create compelling apps for business users. So, as the topic says, this is about looking at an app and thinking about some of the tips that are available for improving that app for others to use or for your own personal usage. So, during this presentation, I will actually be showing you how you can take many of these tips and tricks and actually use them within ClickSense. So let's get started with the first one. So here's an app. It's about New York City bikes. So in New York, you can go there as a tourist or as a person living in New York. You can rent a bike for a certain amount of time, high-level KPIs together with a description. For example, what the amount of stations, what is the amount of rides, what is the total trip duration, and also some information about that we have age, for example, membership, we have if there's have a pass or not. But also in this first sheet, what I try to do is to get a comfort zone for the app. So I try to tell a user what this app is about, and mainly to do that, I'm using icons, images, and potentially logos. So what I'm going to do now is show you some ways that you can add images into ClickSense. So I prepared slightly here. I have two text and image objects. I'm going to down here add in a image of a city bike, since this is an app about the usage of city bikes. You can see here that I have a couple of options available in the property panel. So for example, I can have always fit, I can have fit to width, fit to height, stretch to fit, or original size. So let's go through them. Original size means that I actually use the pixel size that the image is. So most cases this is not actually going to work because the text and image object here then actually needs to match that pixel size. The option I like best is actually always fit. So what we do then with the bicycle is that we actually look at the width, look at the height, and we take the one that is closest and use that one. It does create some issues sometimes with a lot of white space, for example, above or below or on the sides, depending on the aspect ratio. But I think it's better than, for example, using fit to width or fit to height, which may create scaling issues when you're using the wrong aspect ratio. You can also use stretch to fit, but if you have a picture like this, that it's actually more pixel perfect, where aspect ratio is of interest, it does create some skewing of the image as you try to resize it. So for pixel images, I try to use always fit. But there's also other types of images. For example, you can use vector images or you can use images that are scalable. So in this case here, I'm going to go in and I'm going to add in a top banner. As you can see here, it's not really pixel perfect. I can actually have stretch to fit and I can move it around and it adapts to the sizes given. So really trying to use that type of image that is scalable and then using stretch to fit to make it fill up all the space up here. So potentially a slightly better entrance to the app, seeing the images with bicycle, seeing the top banner here. But what I can also do is add in a logo. So in this case here, I'm using ClickSense 3.1, so I'm using functionality that's been available for a while. And I'm going to go in here and brand the app. So you can see here in the app settings that I have an image suggestion. And I can go in here and I can add in, for example, the Click logo. And now if I insert it, it's going to be available up here on the top right corner, or I can put it in the middle, or I can put it on the right. What I can also do is that I can add in a background color for the sheet header. So in this case here, might add in some blue one, might actually make it so it does that nice gradient, and then also change the font color so that it's readable on this background. Now, one of the issues with using an image with a logo is that sometimes it's not actually transparent. So in this case here, the area behind click is going to really come forward and actually look very much out of place. So an option then is when you're using a logo like this, that you use a logo that has a transparent background. So when I insert it in here, you can see here that the blue background shines through and you don't have that white space. So that's some options when it comes to images, either using pixel perfect ones or using vector ones. And also when you're using logos, make sure that they are transparent if you want to have a background color. So that's tip number one. The second one is about dashboard overload. So I can't tell you how many times I've gone into a dashboard and I've just seen many objects and I have no idea where to start. So some of the KPIs are in the top left corner. That's of course interesting because then it's potentially more important. I have some filters available and so on. But then the rest of the charts just seems spread out to me with no real order. I have no real idea where to look first. It just feels like the author of this sheet tried to add in as much content as possible. So what I try to do when I build dashboards for others to use is that a limited amount of visualization objects. I also don't actually have in as many filters as I potentially could be, because I really want the user to use the visualization objects for selecting or using the associated search or the selection tools that are available. I also use the 80-20 rule, which means that I build 20% of the objects required to meet 80% of the goals. And then of course I keep iterating, I talk to my users, I see what's of interest to them, if they're using a certain visualization or not, I might replace it and so on. But less is often more compared to overcrowding a user. The third tip is about space and symmetry. So if you're, for example, examining a topic that has, for example, 2 or 3 different views, in this case I'm looking at the bicycle rides by gender, I'm looking at female rides, I'm looking at male rides, what I can do then is use symmetry. So I can use the KPI values up here at the top to represent the female rides and male rides, and I can color them, for example, with red for females, blue for males, and then I'll know using a silent legend across the app that anything that is this blue color often is for male rides and the red one is for female rides. And I can also mirror it here so that if I have a line chart telling me the amount of riders percentage over time, I can mirror it and have a blue one over here. And then at the bottom I'm using a bar chart and a map, and this is pretty much up to you if you want to mirror it or if you just want to take the bar chart on the left and the map on the right. But grouping objects together that have a strong relationship or shared relevance makes people have an easier time doing analysis. I can look from the top to the bottom, I can follow the content for the female writers, I can follow the content for the male writers. And also sometimes tries to leave some space between objects. There is actually no real point in trying to fill all the grid cells. Sometimes a little bit of space makes it easier for a user to focus on that part of the dashboard. The fourth tip is about data attributes. So I'm going to use a really simple version. There are more advanced versions out there. But what I try to do when I look at data is to classify what type of data is. And in this case, I'm using 4 different categories. I'm using ratios, intervals, ordinals, and nominals. So starting with ratios, they are most often your measures. And they're most often numbers that you can do arithmetic operations on. For example, I have a cost for a product. I have a number of products that I want to produce. I have a margin on top of that. I may have some taxes on top of that and so on. So I can take those numbers, I can multiply them, I can divide them, subtract, and add to those numbers. Intervals are often numbers also, or measures, but there's a slight difference between them that you can't really add and subtract or divide or multiply as you like with them. For example, if you look at temperature, which is an interval, which is a position on a scale from the coldest temperature to the warmest temperature, you cannot actually really go out and say, what was the total temperature this week? What is the sum of temperature in New York across 1 week? Instead, you look at things like what was the temperature at a certain time, or for example, what was the temperature yesterday? What was the difference in temperature today compared to yesterday? So really about the distance and the relationship between these data points. Then you have ordinal, nominal, more often used as your dimensions. When it comes to ordinal, they are data items where we don't know the distance between them, but we know in what order they come. So for example, if I'm using sizes, I know that small is the smallest one, then you have medium, and then large. You don't often have the order small, large, medium. But the other thing is the nominal. So those are data items where you cannot actually say in which order the data items should come. So for example, gender, male, females, equally good. Same thing with sports, soccer and American football. I like both of them. I watch both of them, meaning that I can't really say which one is better or worse. And of course, if I talk to you or any other user out there or person, they're also going to have their own opinion on which sport is the best one. So what's interesting with this is that once you've classified your data, you can start thinking about how you're going to use that data. For example, on the x-axis in a bar chart, on the y-axis, if you're using it as a dimension, if you're using it as a measure, and so on. So a simple example would be that if I have nominal data, I'm using it as a dimension on the x-axis, I should either be sorting it by the alphabetical name of the data item or by the measure I'm using, so from smallest to largest or largest to smallest. Well, instead, if I have ordinal data on the x-axis, I really want to sort it by the order that the data comes. So I would not sort it large, small, medium. I would sort it small, medium, large. And then, as I said before, when it comes to your measures, you should not be using intervals and the sum function, but you could be using things like median, average, or count. And here's some example of it. So in this data set, I have age groups, so they are bucketed. So I have the writer's age, but due to secrecy and so on, it's been bucketed into age group. Now, the things that I should not be doing with an age group, for example, is to take the sum of an age group, because I don't know that that is actually this total sum of all the people's years, if that is of even interest. And I cannot really take an average age group because it's still buckets of data, it's not actual years. And also when I'm using a chart, I should be sorting the chart here at the bottom, the bar chart, by the age group ordering. If I want to do some calculations on it, I can, for example, count age group to see how many people have been registered in an age group. I can do a count distinct age group to see how many different age groups we have. And I can also be looking at the median value of the age group. Now over to the next tip. So that was the data part of building visualization, knowing how you should sort your data, how you should aggregate your data. So just some thinking about data. The next part is how you actually can represent the data within the chart. So in this case, most often you already know what chart to use, but there are different ways of enhancing that chart with more and additional data. For example, you can use position, length, angle, area, volume, different symbols, or the different ways of representing colors. So this is about thinking what is the best way of adding something into a chart. So there's been some experiments back in the 80s and so on, looking at people and how we perceive the different symbols. So the most accurate way of representing data is position. It doesn't have to be a scatter plot with a bubble and an axis. It's actually any type of chart that has an axis, so that you can see, for example, the end of the bar. You can compare it to the chart or the axis, and you have a value on the axis, and you can get the exact number. Then the second best thing is length. So it's quite easy looking at two bars, comparing the length and seeing the ratio between them. And the same thing when it comes to angle, not that much difference. You can look at the larger angle, you can look at the smaller angle, you can say how many times larger the larger one is compared to the small one. But then there's a gap down to area and volume. So as humans, we have a harder time seeing the difference between areas and volumes. So for example, the larger dot here is 5 times as large as a smaller one. It's not that easy as it was when it comes to the length and angle. Then we have a really large gap, so if we're using colors, for example, it's hard to say how many times darker the dark green color is compared to the light green color. That is, of course, if you're not using a Legend. If you have a Legend, then potentially you can look at the color, you can try to find it in Legend, you can get a value. But if you don't have a Legend, it's really hard saying how many times larger. You can just say that the dark green color is darker, which most often means larger. And then it depends on what type of data you have. So that was for your interval and ratios, so most often your measures. But if you're using nominal data or ordinal data, if you want to add in some data to your chart, there are better and worse ways of representing that data. So I'm going to go here and I'm going to show you an example. So I have here the different stations all aggregated together by month. I have the average temperature on the x-axis, and I have the average trip duration on the y-axis. So since this is a scatter plot, I can add in some more information in it using, for example, size or using colors. So what I want to do now is to look at, for example, what is the longest trip duration for each month and how they compare to each other. So what I can do is that I can, for example, use colors in here, and I can add in a legend in here. So I can see here largest value, smallest value, and compare them to each other. But let's say the chart is so small I don't have a space for a legend, then using colors here is one option. But what I can also be doing is that I could be using the size of it. So if I go in here, if I find a measure, if I drag and drop it and add to it, you can see here that the bubbles updates, and I can go in here, I can look at the larger bubble and compare it to a smaller one. So if we go back to how we worked here before when it came to our capabilities, so if I go from top to bottom, you can see here that size comes before color, which means that when I add this data in here, I should most likely be using size because it's easier to perceive it. Unless I actually have a legend together with it, then I could be using colors. And then you can also see here what happens when you use other types of data. For example, if I'm using nominal ones, you can see here that I have female riders, I have male riders, and I also have some unknown riders in my data set. So I could be using colors in here for representing the nominal data, or I could be using size. And in this case, at least for me, it's much easier looking at the colors and seeing the difference. And as I said before, intervals and so on, you could either be using colors or you could be using size. Then the next tip is about using the right chart for the right data. So often you're sitting there with the same type of data, but depending on what type of questions you're interested in, there are different ways of representing that data. For example, do users want to do comparisons? Do they want to do distribution? Do they want to do composition? Do they want to look at relationships? So I'm not saying that you should be using this chart here as a guide and so on and just go straight for it. But think about the simple fact that you have, for example, time data. The best way of representing time data is often a line chart, but if you have few data values, a bar chart might be preferable. Or if you have cyclic data that actually repeats itself, then maybe you should be using one of those specialized plots in being able to see the cycles and being able to determine the length of a cycle. So I'm going to show you some examples here. So let's do comparison over time. So I'm looking at the rides here. I'm looking at the total amount of rides by quarter. So I have 4 values. I can have the option of representing it as a bar chart. I can represent it as an area chart, and there are of course many other ways of representing it. But in this case, I would probably prefer the bar chart because there are so few values. There's not really any type of trend to be able to see in here, which is much easier seeing in an area chart. So really in here, each bar here represents a value for each quarter. It's quite easy to see the actual value, seeing the difference between them, and being able to do comparison. But then if you have, for example, large amount of values, let's say you have the weeks in here, so you can see here, I have to scroll through here, or I need to look at the mini chart, and as I'm looking here across weeks, there is potentially some type of trend or pattern I'm interested in. And it's for me much easier to be able to see that in an area chart, where everything is squeezed together, because I can really look at a point here that has a really high amount of rides in week 3 and compare it to the week after. Much easier seeing the trend here where it goes up and down and seeing the profile across the year compared to this bar chart over here. And then also if I add in, for example, age group, I might be getting in here a group bar chart, or I could be getting a line chart using 2 dimensions. So probably more preferable to use a line chart with 2 dimensions, as it's easier to compare the values for each quarter to each other. But if you're interested in the values per quarter, then maybe a group bar chart is better because you can really go in here by quarter and see which is the highest value, second highest value, and compare them to each other. And then also if you're, for example, doing composition, think about should you be using absolute values, should you be using relative values. So in here I'm looking at the total amount of rides by month. So I have the females, I have the males, and I have the unregistered one where we don't know if it's a male or female. So I can see here that if I'm looking at absolute values, that the amount of rides of course increases here during the summer, and that the unknown gender is introduced here towards March. But I have a really hard time knowing if it's actually the males or the females that are being reduced, or if they are at the same level and it's just the unknown one that's being increased. But if I'm looking at relative values, if I scale this to be using percentages, you can see here that females rides are pretty much constant across the year, but the male rides here, the percentage of male riders is going down as we're getting this gray area in here. And also, if you want to use, for example, simple share of total, you could be using a pie chart. If you have multiple components, you could be using a stacked bar chart, or you could be using a tree map. So really think about what type of data you have, what aggregations are possible, how can you enhance the charts, but also what are the most common questions that people are asking, what are simple things that they want to know from the chart. That really makes you have to decide what chart to use to represent the data. And then when it comes to charts, I really want to distinguish between what you could call the normal charts, which is the bar chart, line chart, pie chart, tree map, charts that are really easy for anyone to understand, and the ones that are maybe more for beauty, or the ones that are more for data scientists. So there are many charts out there that are probably not optimal when it comes to visualizing and displaying data, but may be perceived more interesting to your end users and so on. For example, a packed bubble chart or a sunburst chart. So they are great for beauty, but probably not for analysis compared to the other charts. Or you could be using some more complex ones as for data scientists. So on the left hand side here we have a scatter matrix. So instead of having just one scatter plot with an x-axis and a y-axis and a dimension, I'm actually using the same dimension across all these scatter plots, but I'm switching out the y and the x-axis to be able to see all possible correlations across 5 different measures. So that's why in the middle here you get this straight line, because I'm using the same measure on the x-axis as the y-axis. But I can also see here, as I change some of the x-axis and the y-axis, there's, for example, negative linear correlation, positive correlation, and so on. Another option to use is the parallel coordinates. So you can see in here that I have the same amount of measures. I have 5 different measures. Each one here is an axis. It has the lowest value in the data set. It has the highest value in the data set. And then each line in here is a month. So for each month I go in here and I look at the total amount of rides, and I put a position for that line here on the axis. Then I look at the next measure, which is the average temperature, and look at the average temperature for that month, and I draw a straight line between those two values, and then as it continues here across all the different measures. So I'm not going to have the time to really talk through this chart, but what it does give you is an illustration of what are the highest value, what are the lowest value for each measure. It also tells you if there's any type of correlation between the measures. So for example, I can see here that if I have a high amount of riders, it's most often a high average temperature. While if there's a high average temperature, the average age of the people bicycling is quite low. So the lines go here from the top to the bottom, or from the bottom to the top, and creating a cross in here, which means that it's a negative linear correlation. So both of these charts are really great to use when it comes to working with the data potentially for yourself, or if you have data scientists as your audience, but it's something that you should probably not bring to a board meeting and spend the first 10 minutes trying to explain to the board of directors and so on what type of chart you've been using. Then the next tip is to think about the audience. Does your visualization make it easy for users to answer the questions they have? So a simple example would be here, if I go to the sheet and if I show you the left-hand chart here. So what I'm doing here is that I'm looking at across all these 332 stations. I'm looking at the amount of female riders, I'm looking at the amount of male riders, and what I want to do is to look at the relationship between them. Now the first thing that I have to do as a user looking at this chart is to go in here. I need to look at one of these stations. I need to see that it's above 80,000, it's above 12,000, and I need to start doing some mathematics. So I need to think about what is the ratio between 80 and 12. So in this case it's somewhere between 6 or 7. And then I can say how many more times more male riders we have compared to female riders. So you're actually making your users think about the number instead of seeing it within the chart. An option to that would be, for example, to look at the gender distribution by percentage. And what's interesting in here is, as you've seen earlier, is that we don't only have male and female riders, we also have unknown riders. So in this case here, I can actually see here that Central Park, there's about 9% female riders, 35% male riders, and the rest are actually unknown. And what I'm also doing in here is that I'm adding in the bubble size here to indicate the amount of riders. But the main question for a user here would be to see what is the ratio between males and females, and I can easily look at that and get the exact value by looking at the percentages. So not really having to think in the same way that I have to do with the left-hand chart. And if you want, you can go really advanced on this. So this is from a blog talking about percentile distribution. So what I've done here is that I normalized the data. I'm looking at percentiles. So this 0 percentile, 100 percentile, meaning what is the order of female riders and male riders. Then I can also color it by, for example, if it's above average ride, below average ride. And I can do a little bit more of scientific questioning of the data set. So really transforming the data to what the user is looking for. So the next tip is about time. So one of the things that we introduced in 3.0 is what we call a time-aware line chart. So I'm going to go in here and demo how it works. So what's interesting with this chart is that it compresses the data. So for example, in here I'm looking at total amount of rides by date. As you can see here, I have the 1st of January, I have the last of December, and everything fits within one screen. So I can see here that there are certain days, for some odd reasons, really low amount of riders and so on. But the reason why we call it a time aware is that we added in functionality that is just not available in other charts or if you're not using time or continuous data. So I can go in here at the bottom, I can use the mini chart, and I can change the focus, and I can actually start zooming in on certain days to see the values. Or I can use my mouse wheel, or on a touch tablet I can just pinch and I can start zooming in. As you can see here, I had years here, I had months on the axis, but as I continue to zoom in, you'll see that we're actually going to change to dates. And then as I continue to zoom in, I'm going to go down into actually hours, minutes, seconds, and so on. In this case, I only have data on a daily level, but I can see here that there's a low amount of riders on this date. Now, what's really interesting is that you can actually use one of these time-aware charts, and you can pretty much easily build it if you used our visual data prep to load in the data, and we have identified it as a time data. Or you can go into the load script and you can modify it, use an auto calendar, and add the tags to it. So what I'm going to do here is create a chart, and I'm going to use in the start time date. And I'm also going to look at the total rides. So I'm going to build what I had before. So I'm also going to change it to an area chart because it's representing an amount instead of value. And you can see here it was quite easy to build this chart, and out of the box you're getting this time aware stuff. But what you can also do for your users is to add in alternative dimensions. So I can go in here and I can look at the start time, and I can add in, for example, the quarter as an alternative. I can add in, if I go back here, I can add in the month, or I could be adding in the week. So all of these fields are created when you load in a date field. So we're creating the buckets like quarter, months, week, whatever you want to modify the load script to do. So in here now in analysis, you can see that the x-axis down here slightly changed. I can click on the value here. I can say that I want to look at it by quarter, so not as many values. I can look at it by month, so we should be having 12 values. Or I can look at it by week. So everything in here adapts, and as I start zooming in, you can see the weeks, you can see the dates, and so on. So really making the chart aware of time and giving you the different options of what time resolution do you want to display the data on. And of course, it's not really just a time-aware chart, it has a continuous axis. So you can, for example, add in what would normally be a measure or a numeric value to the x-axis. So in this case, I've added in the temperature, or the maximum temperature per day. And I'm looking at the total amount of rides. And I can see here that when it's really cold, not as many rides. The preferred temperature seems to be here above 20s, at least when it comes to Celsius. And then as it gets really warmer, the amount of riders drops off. And I can also be looking at this per gender. So really using that continuous axis either for time data or for other types of continuous data. And now we're reaching the end, so I really want to end and talk about colors. It's one of my favorite topics, and if you go to my blog, you'll see there that I've talked a lot about colors and how to use it and so on. So the best case for colors is actually not to use any colors at all in a chart, unless you think that there is of interest to add in additional information. So in the case down here, adding a second dimension, I've added a gender, and of course I want to use the color here to distinguish the different genders from each other. Or if I use a group bar chart, I can use the colors to indicate the groups. Now with ClickSense 3.0, it's also really easy to add in colors to your tables. Or you can, for example, look at colors when it comes to seeing the gender, which is the highest amount of females or males riding per station. Or you can have a bar chart looking at total rides and comparing it to trip duration. So what I've done in all of these charts is that I've thought about the colors and I've thought about what type of additional data I can actually use in the chart. And I'm going to show you examples of how you can create this. So what I want to do is that I want to go to a sheet here. And I have two charts prepared. I have a scatter plot looking at the total rides, looking at the dates, looking at the average trip duration, and I also have a bar chart looking at the dates and the total rides. So I can go in here and I can say, for example, that since I have the months in here, I also want to color it by quarter because I really want to see which of these quarters is the most amount of rides. So I have another one up here, a certain date, which is the 13th of February that stands out. But also most of Q1 rides are towards the left here. There are more people actually riding bikes during other quarters, and the most popular one seems to be either Q2 or Q3. Or if I have a bar chart, I'm looking at the total rides, I'm looking at the dates. I could also be adding in a measure such as the temperature. So say I want to color by the temperature. If I go in here, you can see that the highest temperature is red, the lowest temperature is blue, and there's more people riding bikes when it's a high temperature. And then as we come down here, there are actually certain areas where the temperature is lower, where there are certain dates that more people are riding, despite the temperature being slightly colder compared to other dates. So that was really my presentation, and I hope you learned a few more things. But I would also say that the most important rule is actually talk to your users and engage them to see what would suit them best. Because not every person is the same and not every organization is the same. So really see which of these tips and tricks and other tips and tricks you can use to enhance your dashboards. And as a summary, a good user experience will help drive adaptation if you use the natural skills of human, perception, color usage, and so on. It's much easier to see the data and understand the data. Also, using images, using symmetry and other dashboarding techniques will make people more enjoy using your dashboards. And also, if you use the best practice, if you don't make the user have to think about the data, they have an easier time finding insight. Now, many of these tips and tricks are also available in our white paper. Just Google good practices for developing user experience in ClickSense, or go to my blog to learn a little bit more about some of these tips and tricks. So thank you for spending time together with me today, and I hope that you can go out now, look at your dashboards, look at potential improvements, and make your user or your user's experience a better time. Thank you.